What is up, everyone? You are on this video because you're probably starting to do your enthalpy or heat stoichiometry homework. Now, in the previous unit, all about stoichiometry, we did stoichiometry calculations, except for we were trying to go from a quantity of something to a quantity of another thing. And we did a really good job with this, going from grams of sulfur to grams of sulfur dioxide. Now, in this unit, the thermochemistry unit, we're focusing primarily on heat. We're focusing on how much energy can either be lost or gained in a chemical reaction. So this stoic is going to look very similar to the previous stoic, except for now we're calculating with it for a different value. So in this first example, how much heat is produced when 85 grams of sulfur reacts according to the reaction below? So we have sulfur reacting with oxygen to produce sulfur dioxide. We have this delta H value off to the right, which is the change in energy. The change in energy from that reaction. Because this reaction, if you look, you see that this reaction is negative. That means that it is an exothermic reaction. We are releasing that energy. That's how much energy would be released in this reaction. But we want to know how much heat is produced or released when just from the sulfurs in that reaction. So we're starting with 85 grams of sulfur. And we want to do our traditional stoichiometry T-chart right here. Because we have grams of sulfur on the top, we want to put grams of sulfur on the bottom. Looking at the periodic table, you'll see that 1 mole of sulfur has a mass of 32.07 grams. So now grams cancel, leaving us with moles of sulfur. Now the question is asking how much heat is produced. So we want our final unit to be in the unit for heat, or energy, which is kilojoules. So now looking at the balanced chemical equation, we can see that we have 2 moles of sulfur because we want moles to cancel. Those 2 moles of sulfur contribute to the overall heat of the reaction, which is negative 792. Remember, we want to know how much heat is produced just from the sulfurs in this reaction, not overall. So that cancels out our moles. So now we're just going to go ahead and plug this in. We're going to take our calculators. We're going to do 85 times negative 792. Remember, that sign is important because now we're dealing with endo, exo, positive, negative. So we want to make sure we're not losing that negative sign. Divide it by 32.07 times 2. And what I'm getting is a value of negative 1,049. Negative 1,049 kilojoules of energy were produced or released from the sulfurs in that chemical reaction. So that would be my answer. So as you can see, very similar look to normal stoichiometry, or going from grams of a quantity of one thing to a quantity of another, except for now we're using this energy value instead. So you have 4 examples down below where you're doing very similar calculations. Use this top example as a model. You should have no problem with this. I'll catch you guys in the next video. Have a good one.